Okay, so thank you very much to everyone to the other presentations I've seen so far. I have been sort of lying back and watching those as best I can, yeah, I've been working very closely with the CAA, so Callum and Kevin and Ed, especially at BT for quite some time now. Essentially, HexCam has been running for just over a decade now, and well, 2012 I think we started, so nearly just over 12 years. We were operator ID 117, so fairly early into the market, and through that time we've built up the number of the complexity of our OSCs through the times. So I'm going to talk a little bit about what sort of our current OSCs we have at the moment, a little bit about risk quantification, a little bit about C2 link and connectivity, and that will tie in nicely with what Ed was saying. And then I'm going to speak a little bit about the TRA sandbox, or the BVLOS sandbox that we're involved with at the moment. Okay, so our current operational authorizations over here. So we have several parts to our OSC that we work at the moment. So the first is the standard VLOS out to 850 meters. So that allows us to say, rather than the standard 500 meters that you can do under PDRA 01, that allows us to operate out to 850 meters. And that'll come into play a little bit later on when I'm talking about how we mix these authorizations together. The second one, and that I'll be talking about mostly throughout this presentation, is our BVLOS VM, or what used to be called EVLOS operations. And that's up to 2.5 kilometers from the remote pilot, or from a remote pilot. Thirdly is a control handover. So this allows us to work with two separate controllers, two separate pilots, remote pilot 1 and remote pilot 2, who are geographically separated, and we're able to hand over control of the drone from one person, or one pilot, to the other pilot. We do have reduced separation distances down to sort of 10 meters and 20 meters, but again, I'm not going to major on that today, because that's what we're doing. Talking about mainly is the BVLOS side of things. And most importantly is the final one, which is the overflight of uninvolved persons. This was quite a tricky one to achieve, and we did that in sort of December last year or so. And this was really in response to the changes in that the current swing of the CAA is away from the bubble, that 50-meter bubble, into a sort of horizontal separation distances. And if you're trying to work at a 50-meter horizontal separation distance, that's no good if you're trying to work 2.5 or 3 kilometers away from or 2.5 kilometers away from the remote pilot. So what do we do at the moment? Well, this is a fairly sort of standard configuration for us when we're doing sort of coastal erosion surveys. You have a crew of 3. Well, actually, it's probably a crew of 4 if you include the surveyor who puts out the ground control units. This is the southern part on the left-hand side of the screen, the southern part of a 7-kilometer coastal erosion survey. Using the permissions that we've got at the moment, we're able to conduct that survey inside 2 hours. That means that we can conduct just an hour either side of the low water mark of the low tide, which means we can collect the most intertidal data that's possible along this entire 7-kilometer area. In the graphic on the left, you can see the southern half of this. You've got the at the top, you've got the remote pilot 1 position, and that's the takeoff and landing site. We're working south from that is the visual observer, and then south from that is remote pilot 2. So a standard sort of route for us is to take off from that takeoff and landing site, fly over, hand over visual command to the visual observer in the center, and then hand over control and visual command over to the pilot in the south, who can then fly those segments. That way, we've been heading out to, well, I've got sort of 3.6 kilometers we've got there, and telemetry is good at that range using the 300, which was used on this particular project. We are, however, approaching the limits of the standard DJI C2 links, and this is where we start to we could push things further on from this, but we're now at the limits of C2 connectivity, and that's where my continuing bothering of Ed comes into play as we're working together to try and convert this into the ability to use the mobile phone network for the C2 link. We also cover handover takeover, okay, over a very long corridor. So this is 1/3 of a 60-kilometer corridor that we do regular surveys on. It's a construction corridor for the Vanguard offshore wind farm, and this is the onshore cable route that goes along. As I say, 20 kilometers of construction corridor, and we survey that in under 6.5 hours. I think 6 hours was 6 hours the record a couple of days ago. We just use 7 takeoff and landing sites throughout. But the great thing about using this particular technique is that the drone is never on the ground for more than about 2 or 3 minutes while you complete the between flight checks and complete the battery swaps. So you'll have your remote pilot 1 will take off, fly their own segment, hand over visual command to the VO in the middle. And when that segment is complete, hand over to remote pilot 2, who brings it down, lands it, changes the batteries, flies their own local segment, and while they're flying that local segment, RP1 and RP2 leapfrog around and to get into position for the next segments, and that I say continues. So we're not having the link time in there, as I say, is down to about 2 or 3 minutes. You're not having to strip the drone down, to take it back in the car, drive round, and set up and go again. That means the risk is massively reduced. If you've stripped down and set up the drone over sort of 70 odd times in a couple of day period, then the chances of you making a mistake with making sure a battery is correctly fitted or a prop is installed properly is increased significantly. So by doing this, we've massively reduced the risk of that human error creeping in on setups. The next phase of the OSC, which is in with the CAA at the moment, is to remove that VO in the middle. We've done quite a lot of studies on this, and we've worked out that actually it can be done just as safely by not having the VO in the middle and using sort of the parallax effect of having the 2 VOs on either side, or the RPs on either side, to be able to sort of control that airspace. Okay, so I'll chat a little bit now about overflight of uninvolved persons. So this is again a survey that we carry out in the middle of Nottingham. So as you can see, quite a significant sort of built-up area there, and again using our BVLOS VM procedures, we're able to hand over, take off and land from a single, well, 2 locations in this particular scenario, and fly over so it's in range or within visual range of one of the visual observers. So part of the argument around this is definitely the risk quantification element. How do you manage the ground risk on that? Again, a few years ago, this was possible within the regulations to work out how you could do this under PDRA 01 and use that bubble. But actually, that's not where we want to go. There is still a significant risk there if that drone does have a loss of control event that is going to come down and potentially hit somebody. So we did a lot of work quantifying the risk. And again, part of this was the risk quantification workshop that Owen and Alex have been running as part of ARPAS. But I've been working with Owen again for some time as an aside to that, to make sure that we can do this all safely. So we have essentially done the numbers, and as long as we follow our procedures, then we are cleared to overfly uninvolved people, up to and including up to a risk factor of 1 × 10⁻⁶. That's where we've settled with the CAA. It was quite an interesting challenge working again with the ARPAS sector team. To be able to sort of justify these numbers and make sure that the figures going into our calculations were, say, acceptable both by us and by the CAA. And again, they've actually been really helpful on achieving that. One of the biggest issues we have around these areas has now become the C2 link. So there's a significant amount of structural shielding. You might be able to hand over visual command of that drone to the visual observer who's looking after it visually, but you get quite a lot of structural shielding in the built-up areas, and if you don't have that radio line of sight between the controller and the drone, then you're just turning into return to home scenarios, and you're just adding additional stress and other factors into the problem. So there's a fair amount of dashing around within that area, not to necessarily maintain that visual line of sight, but to maintain that radio line of sight between the controller and the drone itself. So again, once we've nailed this particular C2 link issue with the mobile network, then that'll be a good day. And again, working with Ed and the team at BT, we're hoping to get that going towards the end of this year. Which will be great. So where are we all going with all of this? Well, the TRA Sandbox was a trial that was put out by the CAA last year, and is now it's become the BVLOS Sandbox, which you guys may or may not know a huge amount about. We were successful. One of six companies successfully got into the TRA Sandbox this year. And our project is to run the 60-kilometer construction corridor that we currently fly using our BVLOS VM procedures, and using that leapfrog technique that I was talking to you earlier about. And we want to fly the entire length of that corridor from our office. So we happen to be particularly close to this corridor. So if you can see it's sort of a T-shaped, and at the bottom of the center of that T is where our headquarters is, our little porter cabin on the airfield at Felthorpe Airfield, which is inside the Class D airspace for Norwich International Airport. So the project will be essentially proving accommodation airspace and the move from accommodation airspace into integrated airspace. So again, flying the drone over the C2 link, the C2 link provided by on the BT mobile network, and flying doing all of the takeoff and landings purely from the airfield that we're operating at, and then flying that entire 60-kilometer length corridor over that mobile network. So there's quite a lot to do in the sort of air risk quantification side of things, and again, very closely working with Owen and with Alex on that particular side of the project. One of the things that we're doing is improving the EC network at low level. So there's already pretty good coverage over most of the UK for electronic conspicuity for aircraft operating at around a sort of 1,000 feet and above. But really, we're not interested in if we can see an aircraft at 1,000 feet. We want to know if we can see the aircraft knocking around at 200 feet. We want to see that Apache or that low-level RAF machine down at sort of 100, 200 feet or so, because those are the areas that we are interested in. So in order to do that, we're working with Pilot Aware, and we're putting in another load of sensors across Norfolk to bring that base level coverage of the EC network down to as close to ground level as we can get. And that means that we'll have a better picture of what that low level airspace is doing. That is a very brief overview to what we've been doing and what we're heading to, and I'm more than happy to sort of answer any questions on that. If you want to know more about the Vanguard TRA sandbox, then please feel free to snap that QR code. I'll leave it up. That'll take you to our web page with our consultation phase on it. The consultation is an informal consultation at the moment, as we go through the formal ACP process with the CAA to put in the accommodation aspect. The formal process will go live hopefully within the next month or so, but for the moment this is an informal consultation, and you can see more details of what we're doing there. So yeah, thanks very much for your attention, and yeah, happy to take any questions. Thank you.
I don't know if you can hear us, Rowley. Can you hear us?
I can hear you when you're speaking, and I can see everybody clapping. So thank you. So
I guess people will also have the opportunity to ask you questions directly. I see one on the Slido, which actually I'm interested in as well. Rowley, how are you quantifying ground risk? What mitigation is required? Is overflight of roads and rail included with the overflight of people OSC?
Yes, it is. So the risk quantification is based on probability. So you've got to look at the probability of the drone having a critical failure, and then the probability of it having a critical failure while it is in an area where there are uninvolved people. And then once you've got the probability of those two, you then times that by the probability of it striking a person in that area. So if you've got if you imagine yourself hovering over a football pitch, and there's one person on the ground, or there are no people on that football pitch, then the probability of the drone having a failure and hitting somebody is effectively zero. Now, if you start to up the numbers of people on that football pitch, you start to increase the probability of actually hitting somebody if the drone fails. And so this is what the risk quantification course sort of teaches us about. And you can work out. You have to start off with a tolerable level of safety. And we essentially followed the SORA 2.5 guidance, which gives a 1 times 10 to the minus 6. So that's a 1 in a million chance of harming or killing somebody on the ground. We've gone above and beyond that because we didn't go through the maths of if your drone strikes somebody, what's the probability of killing them. We decided not to go through that particular exercise. We just decided we wouldn't want to cause harm to anybody. So we've gone down the route of a 1 times 10 to the minus 6 chance of harming anybody. So again, it's just a fairly complicated mathematical process of proving the probability. And again, Owen's your man to talk to on that particular side.
All right, brilliant.
Did that answer the question?
Yeah, you did, absolutely. So, thank you very much, Rolly. And I mean, we do hope that your back is going to be on the recovery quickly. Thanks very much. It's super interesting. And it's good to see that actually under the OSC, you managed to accomplish quite a bit of approvals to perform your missions.
Yeah, thank you very much.
Thank you.
Thanks, everybody.